Alright, welcome back to the SciMax channel. I'm going to talk today about a project I've been working on for a few weeks now called litdb. This is a sort of the next sequence in projects that I've been working on, like OrGraph and other ideas about searching the scientific literature and finding things in it. As you know, if you work in the field of science, the number of papers published a year is something on the order of 1 million a year, and it's very difficult to keep up, especially in fast-moving fields like machine learning, water splitting, CO2 reduction, things that are related to climate. There can be hundreds of papers per week that come out that you want to be able to sift through. So searches like Google Search, Google Scholar, Scopus, there's all kinds of search engines. And what I was interested in is how can I take all of the information that's out there and find things in a more easily. So out of this came this idea of litdb. So this is a project where you're going to curate a database of all these papers. And then litdb has some search tools. It has the regular full text search for keywords and things that you're accustomed to. But we have a new concept of a vector search. And a vector search is where you take your query and turn it into a high-dimensional embedding vector, and then you do a vector search for similar vectors that point to similar documents. All right, so that's what I'm going to show you today is kind of like the idea, and I'll just walk through how I have been using it. So I'm going to start by looking at this paper here, Correlations in Coverage-Dependent Atomic Adsorption. This is a paper I wrote a long time ago, and in 2009. And we're going to use this as the starting point to find papers about the coverage dependence of nitrogen in ammonia synthesis. So over here, we're going to first initialize litdb. And I'm in a directory here that is in a temp file, a temp directory. So I'm just going to do litdb init, and it's going to prompt me for an email address. And then it's going to prompt me for an API key for OpenAlex. I'm not going to use that feature today, so you don't really need one. Eventually, you can use, if you do have the premium key, you can use it to update filters, and I'll show that in a future video. All right, so the first thing I'm going to do is copy this DOI here, and we're going to just say litdb add that DOI, and I guess I need to delete a bunch of junk here from the URL. And I'm going to go ahead and tell it to get the references and citing and related. So this should add all of the references from this paper that OpenAlex knows about, and any papers that are citing this will also get added. So that it looks like there's about 30 references maybe. And I can see over here there should be about 87 citing articles. And so let's see, that's going to be like 120. And then related is from OpenAlex. There's usually 10 of those. So from one command, we're getting about 130 applications, papers that will get downloaded into the database. The number of citing articles might differ just because of the way OpenAlex counts it. But it says 92, so okay. So it takes, between 1 and 2 seconds per paper. And what's happening now is we've run a query against OpenAlex. We are storing the title and abstract for each paper. We're also generating an embedding vector for each one of those, and that's all getting stored in a libsql SQLite database. And then we'll be able to search that in a moment as soon as it's done doing this. Obviously up here you should use your own email address. That's used for all of the requests to OpenAlex in case you do something that causes a problem, they'll be able to get in touch with you and figure out what's happening. Okay, so that looks like it's done. Let's run litdb about. So litdb is kind of like a git, like git. It has subcommands, and this will just give you some information about the database, how many sources we have in it, where it's located. So we have 133 sources, and it takes up a tiny amount of memory at the moment. I have a database with close to 60,000 sources in it, and it's under 6 gigabytes in size. But now that we have this, we can do a search. So let's start with full text. So litdb full text, and I'll just search for coverage. And this is going to find all of the title abstracts that have the word coverage in them. There should be lots of them, but it shows me, say, the top 3. And this is the BM25 score. SQLite makes it negative, so more negative is better. So this is the top one. We can also do a vector search. So I'll type vsearch, and let's say coverage dependent absorption energy of nitrogen, and see what comes up. So it's going to turn that into a vector, and then it's doing a vector search inside a SQLite database and showing me these hits. So let's start at the top. We have correlations of coverage dependent. This is the first one that I wrote, and this one actually does have nitrogen in it. We also have this one that is related to oxygen, and let's refine it for in ammonia synthesis. And for fun, let's do -I. That's going to make it iterative. So here it's finding 3, and it's got these cosine distances. Here smaller is better, and so it says, do we want to find better matches? I'm going to say yes, because the best matches are typically in the range of like 0.2 to 0.3. And so now what we'll do is for each one of these, we're going to retrieve the references and other things that are related. And the idea in litdb is that we're close, but probably some reference or paper that cites it is even closer. And so we just download all of them, and then we can repeat, and it will do this until we say stop looking or it doesn't find anything new. You can set there to be more than 3 if you want to see the top 5 or something like that as well. So here it's doing the references, related, and citations for each one. It's a little bit boring to watch, but you can read the text above it while it's going if you like. what we're going to be looking for is changes in these three numbers here, the 0.41, 0.417. If we get numbers that are smaller, it means that we found a better reference in the samples that we just downloaded. And if it is small enough, it might be a reasonable place for you to just stop and see what's there. That's what we're going to do, because you can run this as long as you want to keep downloading and expanding the references from each new thing that you get. Okay, so it did find something that's a little bit closer. I'm going to go ahead and say no, and see what we get. So we have a paper on catalytic resonance of ammonia synthesis. That sounds pretty reasonable. Actually, these two are basically the same, but look like different versions. And then the number one is also related to ammonia. So that seems pretty useful. Already you can keep running this as often as you want. Maybe it's also helpful to think that if this paper I wrote was relevant, maybe there are other papers I wrote that are relevant. So we can do a search for the author name, author search for John Kitchen, and this is going to check OpenAlex and look for authors that have my name. And then you see these work IDs, and you can scroll through. This top one is me. And so now we're just going to add litdb, add the author, and now this will get all of the papers I've written, and then they will be part of the database. Papers is sort of a loose concept here. OpenAlex indexes a lot of things that include some conference proceedings and some other documents. I know in my record there are some papers that are not actually mine, but from other John Kitchens. That's a limitation of what's possible with OpenAlex at the moment. But this will run. I'll go ahead and stop it and show you some other things. So let's check out what we have in the database now. So we have now 324 papers that we have downloaded. I'll try this one there just for fun. There is a GPT. Describe the coverage dependence of nitrogen in ammonia synthesis. So this is just using a local ollama with the llama 2 as the model. There are other models you can use. This doesn't happen very fast, so it takes under a second to embed the prompt. It takes very little time to find the top three. We use the top three matches by vector search for basically as a RAG, retrieval augmented generation. And then depending on what's happening on this is a 4-year-old Intel Mac that I'm running this on. It can take anywhere from 30 seconds to a minute or two to generate some text. But it'll generate something in response to that. There's a little prompt engineering behind the scenes. and then it shows the top 3 documents that were used with RAG at the end. Could be faster if we use some cloud GPT, but all of those require accounts, and sometimes you have to pay for them. And one of the reasons I made this was to do everything totally local so that nothing goes out to the cloud. Other than, I mean, of course, we have to make searches and queries at OpenAlex, but we aren't sending our own text to them. And we also get to use our own RAG system any way we see fit in this. But it's so slow, I feel like you could read these documents almost as fast as the text is generated. Seems faster on a M2 laptop I have at work. It's kind of super slow today. Let's see if that comes out later. litdb -- help. Maybe we'll see something. Maybe not. I don't know. So there's a bunch of commands in here that you might be interested in. We can use bibtec or citation to get some citation keys, and unpaywall to find PDFs. So let's try those out. So the entries are stored as PDF or as these DOIs. So litdb citation like this should just print out a reasonably formatted citation string. So there it is. And if we use BibTeX, then it should output a BibTeX entry that you can send to your favorite BibTeX file. So that is it right there. Let's see what happens if we do show. So this is the entry that is stored. We have the source. This is the title and citation. This is the abstract that is searchable. What else was in here? Oh yeah, unpaywall. If you want to find a PDF, sometimes these exist, sometimes they don't. This one might not because it's pretty old and was sort of before that. So this one doesn't even exist in there. Web is another one we might look at. Oh, similar is something that's helpful. So let's say I want to find papers that are similar to this one. So what this is going to do is just take the vector for this particular paper. So it's a document level embedding, and then it's going to find 3 related papers. So here we have the correlations. That is actually the first paper. That might be a bug. I thought it should not do that. It should show the next ones. Probing coverage dependence, these are all similar and also written by us, so that's one of the reasons they're so similar. In another video, I'll talk about tags. You can tag papers. Hybrid search is a way to combine the hybrid vector, or it's a hybrid vector and full text search. I think the last thing I'll talk about is the web, the DB web. Single atom alloys, and I'll just say -A, and that will open all of them, I think. So this is just a convenience place. So in one, all right, let's just try web because I can see I have a bug to fix. This is going to open a search for single atom alloys in OpenAlex, and if I add -G, -GS, -PM, maybe let's try -AR. Those are a couple of Google Scholar, PubMed, Archive, and Google. So it's going to open a bunch of tabs where you can look. Down here, it looks like nothing came up in Archive. I don't know what happens. This looks like PubMed, maybe. Maybe I have to log in. You may or may not have to do that. So here are some papers from PubMed. And so you can take these DOIs and add them over here. Google Scholar, similar. You know, lots of ways to interact with finding papers that you might then add to your litdb. This one is just regular Google and OpenAlex. Okay, so obviously I have a little thing to clean up in what gets printed here, and also on here. So that's like a brief summary on or brief introduction to just using litdb in the command line and using it to get citations or BibTeX entries. You can use it to follow an author, to get a DOI, to get references, citations, etc. It all gets stored in this litdb.libsql. So I use libsql instead of vanilla SQLite because libsql has integrated vector search, and this libtoml is the configuration. So we have some details for the embedding. We use all mini LM L6 v2 as the sentence transformers embedding model. Each document gets chunked in with this size and this overlap, and then you pool them by taking the average embedding. And I used llama 2, and if it generated something, it did it in the background, and it was just too slow to wait. I'll probably show that another day on a faster machine where things go more quickly. So yeah, that's it. You can go to the GitHub repo. It is in the video description. In theory, you can pip install this. There are a lot of dependencies, including some for audio, and that might be tricky. At least for me, I had to install port audio, and then I could pip install PyAudio. But you can read all about that in the repo. All right, hope you try it out, see what it's good for. In some future videos, I'll talk about Emacs integration and some other options for adding local files, and cover some other more advanced ways to interact with litdb in the future. All right, have a good day and see you next time.